So here we go. So the fundamental theorem of calculus, part 1. Notice there will be a part 2. That's next time we meet. No, just the 1 and 2. Yeah. Yes, I did.
Tyler.
Hi, Tyler.
Caleb.
Hi, Caleb. Anyway, so what do we have here? Yes, we talked about this last week about how, hey, you got a function. What? Hey, here's A. That's cute. Hey, here's B. That's awesome. And so to find the area between them, you simply take the antiderivative, that's cap f, and then evaluate it at B and evaluate it at A, and you minus them. We mentioned previously the reason for that was, let's say you went all the way back here to 0, for instance, or some C value. This is the same thing as integrating from f of x dx. It's the same thing as going from C to B minus C to A, because it would be going all the way back and then only part way back, and then when you minus them you get the part that you're actually interested in. Huzzah! Nice. Now often of course we'll go to 0, start at 0, we don't have anything, we build up to such and such. How far did I go between these 2 points? Well, I don't know. Where did you start? Doesn't matter, bud. We're talking about we're saying between these 2 values. Okay, so that's the beautiful thing about it. Now, so in this section, whatever section this is, section number 5.3, there's one piece that you need to see. It's a little weird. If you were to integrate this guy here, why did you write it like that? It scares me. Okay, they're the same. And what is the antiderivative of 1 over x? ln of x. Well, almost. It's the ln of the absolute value of x. Because you cannot take the ln of a negative number, but that would be suboptimal. So yeah, nice. Nice, yay, beautiful. Now, question. What would happen if you were to integrate it like this? Well, it would be the ln of b groom minus the ln of a groom. I agree. Or another way to write that would be to do with the who, the what? The ln of b over a. Am I right? What's missing here? Plus c. Right? Plus, oops, no dx, but that's disturbing. Plus c. Remember our rules for exponents and logarithms, right? When you are subtracting logarithms, you're actually subtracting exponents. When you're subtracting exponents, you are dividing. Beautiful. That's one of the few things in this section that was like new today. Oh, scary. Not hard. Nice. Now, nice. Now, next time we meet, we're gonna spend. I'm gonna hint at this today a little bit. We're gonna hint at it just a skosh, and we're gonna see what happens here. I do want to do this problem here before we go any further, though, because I want you to tell me what you think happens on this guy. The integral from 1 to 4. Actually, let's just leave off the 5t for a second. I just leave off the plus 4. If you just had the 5t there, what do you think is going to happen here? What do you think is going to happen? Before you answer, let me give you one of these guys too, just for fun. The sine of 2t. What do you think is going to happen? Wait, there's more. What about the integral of e to the 3x? Oh, these all look like guys we should know the antiderivatives for. Except what? Except what? Because what's different about them? What's different about them? What's different? No. Oh, they're t's. Some of the t's similar. Actually, it doesn't matter. What? Wait, you mean there's something inside? There's a function and a function. So it's like a chain rule. We got to go ask backwards on the chain rule. But Mr. Grimm has a question. Hey, listen, watch this. Let's start with this guy here. What is the sign? What is? Let's go see what sine of 2t looks like just for fun, shall we? If you humor me, please. Here we go. Sine. Yeah, I don't know. I don't need another mom, so it's just kind of annoying. Now, there's that one, and then here's regular sine x. What can you say about the slopes? The slopes on the red one versus the blue one? By how much do you suppose? So in other words, when we were doing that chain rule, that gave us that. We took derivatives, right? So what do you think we're going to do when we antiderivative? We times by 2 and we derivatated. Oh, interesting. So we are going to talk more about this later on, but what we're going to end up doing is this. We're going to do what's called substitution. We're going to say u is equal to 2t. Yes? Therefore, the du would be 2 dt. True that, homie? And so we're going to substitute in here. So instead of sine of 2t, we're going to put in sine of u. And instead of dt, what are you going to put in? Oh, if I knew what dt was, well, I do. It's half of a du, yes? And that's just a constant, so it can go out front, yes? So wait, so basically all I'm doing is just dividing by 2, or dividing by 2. So yeah, basically, yeah. So here you go. So it's going to be a half cosine of u, right? And then what do you think you're going to do? Last thing you're going to do. I don't want u. So what are you going to do? You would plug back in what? 2t. What are you torquing it down to?
Like 125 inch-pounds.
The crank bolt or the pulleys?
The pulley.
Oh, what about the crank bolt?
That was like a 110.
Foot-pounds? Okay, yeah. It's freaked me out a little bit. What can you do about this one here? Probably this number, yeah? But I don't have 3 dx, I have 1 dx, Mr. Groom. I got you. And then off to the races you go, yes? Now, I mention this because for whatever reason these clowns started putting them in this section, but they didn't teach you substitution yet. And that's stupid. Okay? Now, I will say later on substitution gets a lot harder. Okay, well, that's not true. Substitution gets a little harder later on. Okay? So let's do this guy here. That's the one I was going to do right now.
Alright.
But Groom's going to just go crazy. He's going to put the 5t minus pho just for a good time. You with me? Plus 4, sorry. 1 to 4. So I'm going to do the actual shebang. So over here somewhere, look, I got a function and a function. What is du? What is du there?
Wouldn't it be 5t plus 4?
Oh, plus 4, yeah. So what would it be? So what's the derivative? If I take the derivative of u, I get du. What's the derivative of the 5t plus 4? 5 dt. That's right. By the way, another way of saying that, Jace, would be to say du dt is equal to 5, right? I just put the dt to the other side. But here it is. And they're like, oh, that's cute. But look here, all I have over here is a dt. I know. So 1/5 du is dt. Now, some people do this a little differently. I'm going to show you Mr. Groom's preferred method of doing this, so just stick with me. This is my preferred method of doing it. Okay? But we're all different, Kaylin. You probably shouldn't judge. But I do, so go ahead. That's fine. I don't care. I judge the crap out of you. yeah, but no, here. So.
You mean Tyler?
Yeah, Tyler. I judge Tyler all the time. Okay? So this is what Groom would typically do, right? And then, Caitlin, what I'm going to do is I'm going to reverse substitute. This is what I would do. Okay, it's just me. You don't have to do it this way. This is how Groom does it. And then I evaluate from 1 to 4. That's how I do. And so it's 24. And then minus the ln of who? 9, I guess, right? And of course, you could write that, and the book probably does, the ln of 24 over 9. Okay? Or whatever decimal equivalent that is. Miss Chisholm gave me a allergy pill that melted on my tongue. It tasted like pepper, and it was tasty, and my nose kind of dried up on it. They mocked me that it's 7 Benadryl yesterday. Maybe it's not working yet. Yeah, so we good? But now listen, that's how I do it. This is how I always did it. It makes sense to me. Okay? But Kaylin, are these X's or U's here, dear? Or T's or U's? I mean, T's or U's?
T's.
Yes! Wait, but Groom, could we convert them so that they are U's? If you put a 4 in there, you get 24. If you put a 1 in there, you get 9. And so another way to do this, and this is probably Jace's preferred method, because this is how Jace rolls. Whatever. And so then Jace would literally go, well, it's 1/5 ln of u from 24, 9. Ta-da. It's the same thing. Honest to God, it doesn't make any difference to me how you do it. If you convert your x's to u's first, or if you just re-substitute, because you're going to do the same thing either way. But I know some professors who make this, they about have a damn conniption fit when I tell them, oh, I don't teach it that way, typically. Well, what do you mean? That's not what I do. I'm like, no, stupid, you can just re-substitute. But you're doing the same thing. I'm like, I know, so why you haven't fit about it? So, I don't really care if I get the right answer. Okay? To me, it makes more sense to re-substitute in, it always did. I don't problem the other way. And years ago, I used to argue it was more work. It's not more work, it's the same work, it's a different order, right? It's just weird, okay? Maybe you're like the person, you're one of those people who likes to clean your dishes as you go. Bull crap, let's have dinner, let's clean up the dishes when we're done, okay? Wow, broom, stop, it's the same. It's just weird. You're wrong.
Sometimes I feel like it's effective to clean dishes as you go if you have time, but like when you're like getting your plate.
It was an analogy, I got you.
I think what you're saying, like if you have like a group of people over for dinner, you're not gonna be like, well, as soon as you're done, go clean your plate.
Oh yeah, no, for sure. Yeah, it's just weird. All right, what about this one here? Okay, this one's odd. I know if we can do it or not. Should I do that one? Yeah, let's do this one.
Is this from the book
Yeah.
versus Brooke would not come up with 8 over 27?
Thank you for recognizing that. Appreciate that. So, what do you want to do first here?
Right.
No. Did you say divide? I would too. Good call. So I would break this into 2 pieces. This is just me. Divide and conquer. Is that what you meant?
Yeah.
That's what I'd do. And so this is 6/3. It's going to be 10t to the minus 2/3, I think. Minus, that's a 1/3. That's 6/3. 8t to the minus 5/3, I guess. Because, sure, why not? Oh, that's cute. All right, now, let's see. What is the antiderivative of t to the 2/3? Negative 2/3. I don't know, Groom. I got to add 1.
10 t to the third.
So that's 3/3, right? Divide over a third, which is times by 3, right? So 30 t to the 1/3 minus. Now this is going to be t to the minus 2/3. So when I divide by that, it's going to be plus 3/2 times this fella, right? So 3/2 times 6 is 12.
3/2 times 8.
3/2 times 8 is 12 is what I meant. That's what I meant. Right? And then evaluate it from. That was awful kind of them to give us ones that have perfect cube roots. That's bitching. Now, 30 plus 12. Okay, I did the hard part. Minus. If you plug in 8/27, the cube root of that is 2/3. Am I right?
So,
The cube root of 8/27 is 2/3. True dat, homies? So this is going to be 20. And then this is going to be... All right. So take the 1/3, that gives you this. Raise it to the second power, it's going to be 4/9. And it's going to be in the basement, so you're going to end up multiplying by 9/4, I guess, right? That sounds reasonable. I don't believe you, Groom. Oh, it's hurtful, but okay, we'll do it this way. 12 times 2/3 to the negative 2/3. Hold on. Hold on. Oh, it's 8/27, dumbass. Just a minute. I did all the hard. I did it. Okay, never mind. 8/27. It's 27. Is that what I got? Yes. 27. Hot diggity. 27. So I'm going to have 47. It's 42. It's -5. Does that make sense? Let's find out. Let's ask Betsy. Oh, Betsy. 10x to the, what was it? Let's do the top one. X to the 4/3.
yeah.
Oops. Nope.
And then minus 8 to the third.
Oh, poop. Poop. Parentheses. Oh, that's an X. Try a parentheses, dumbass. There we go. And then what is it? Minus
8x to the third. All over x squared.
X to the 1/3?
Yes.
Oh. Ooh, that's ooey. And where are we going from? 8/27.
Got it.
You buy that? You buy that there's more negative area than there's positive area? Nice. I like to check myself because I don't believe sometimes. I'm a weird one, like, what's happening here? Okay, so I always just like to go back and double check myself, see if I'm doing it right. Looks like I'm right. Yeah. Yeah, let's do one more here. No, I don't know, a couple more. I don't know. We'll see. I would say make sure you're in radians. Anytime you're doing integrals or derivatives, always in radians, baby. Man, I don't want to do anything. Yeah.
On the one that you showed us, where you were saying like some people do it this way, this is Groom's way.
Mm-hmm.
On the way that other people do,
Correct.
how do you get the new?
The new U's? Oh yeah. So what would your U be?
On this one,
So you're
3t minus 1.
nice. So then I'm going to put 7 into there,
Okay.
and I'm going to put 2 into there. Again, it's potato vodka, but the other way just made more sense to me when I was a kid. Oh, so I should probably order an alternator for that while I'm thinking about it. Standing on my hand on my butt here. 2008. Volkswagen Beetlejuice. Hey, take a stab. How much does an alternator cost for that stupid Beetle, Jacob?
What, 250?
Yeah, you're pretty good, bud. Ridiculous. Stupid Volkswagen. Come on. What the hell? Come on. Have you done it? You did it already? Does it make sense? You just said I'm done here, Groom. I don't want to be here. Groom, I'm rethinking my life choices right now. I think I'm just going to drop out of high school, etc., etc. What? So, obviously, I feel like du is equal to 1/3, or so 1/3 du is equal to dt, so 1/3 sine u du, and so that came from negative cosine, of course, 3t minus 1, 2 to 7, or whatever I said. Nice. And so, this is the definite integral, dear. I'm going from a to b. I don't need that. Why not? Because it would be f of b plus c minus, parentheses, f of b plus c. The c's go bye. Bye-bye. Well, that's frustrating. I was hoping that would get stuffed in today. Oh well. Oh well. What did you notice? Anything good? Man, those suckers are expensive. Judas Priest. Da 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 da. Hey! Jingle bells, Batman smells, Robin laid an egg. Holy buckets! Good?
Yeah, there's randomness known on the cat.
On the cat?
Yeah.
Where'd you find it? Oh, you got one?
Yeah.
Cool. You got it? Gonna do it? Did we do it? Did we do it? So then you got 1/3 negative cosine of 20 minus a minus, so 1/3 cosine of 5. Is that what you got? Which is what is a decimal? Did you figure it out? What'd you get?
-0.0414.
Negative. Okay, that's cool. I believe you, dear. I'm just asking.
That's what I
Look, I just work here, lady. Don't get upset with me. Okay, I love it. I love it. Now, so yeah, you're doing those today. I would like to try this guy here on just for grins. Just try this one for size. But if I take the integral of the absolute value of x dx. Now, I want you to think about this for a moment. What if I went from -2 to 2? Now we clearly know what this graph looks like. What does he look like? What?
Looked over at you and you're like,
Oh, I'm sorry. What the hell are they doing? Let the record state that they said it's a V. Print.
No, I was thinking of the one from the homework.
Dude, you're awesome.
Yeah,
you were thinking of a negative one. I was like, what are you talking about?
Right? So, question. Positive or negative area?
Positive.
They're both positive, aren't they?
Yeah, positive.
Because they're both above the x-axis, yes?
Yeah.
Now, this is fascinating. You're like, but Groom, I feel like, what if it was just x? What if it was just x? Because x is obviously the brother, the kinfolk, the cousin, if you will, of absolute value. This guy would have an integral of 0, yes? So they can't have the same integral, but they're very awfully similar, I would imagine, yes, in terms of what they look like. So this guy, of course, is x squared, 1/2 x squared, right? Or x squared over 2, that makes you happy. The reason that this becomes 0 because it's 1/2 x squared minus, so from -2 to 2, so you're going to end up with 4 divided by 2 minus 4 divided by 2 is 0, yes? Somehow I need this guy here to be positive, yes? Glad you mentioned that. So this guy here ends up being 1/2 x absolute value of x. Meaning that when I'm on the negative side of things, I get a negative where I want that negative to be, ergo I'm plussing. Yes? Okay, let's try one. Did that work out? So if that's true, -2 to 2, I'm going to get 4 divided by 2 is 2. And then I'm going to get minus, and then I plug it in there, I'm going to get minus a minus 2. So, huzzah. What do you think? Not terrible? Absolute values, I remember the first time I ever saw one of those guys used to freak the bejesus out of me. Just kind of weird me out. But it's not hard, because you can also do it. You can also do this as a piecewise function. True that? You could have also done this. Okay, then. This is equivalent to saying from -2 to 2 of negative x plus, -2 to 0 rather, and then 0 to 2 of x dx, right?
It looks like the 2 is very important.
Oh, he's not that important. He's a big fat 0. He's a big fat loser. That make sense? So back in the day, we did piecewise functions. It made sense. Well, there's a reason we do them. We like them. We like doing piecewise functions. It makes our lives easier in a lot of ways. Yeah? Now, next time we meet, we're doing the fundamental theorem of calculus, part 2. So on part 2 is where we get into talking about, oh, I just had this thought, I have to go to town tonight, but I don't have to go to town tonight, I have to go to town tomorrow night. And I was like, yay, I just got happy. Anyway, so on part 2 is where we marry the two parts, well, here I am, I'm a random teenage girl. Where we marry the two parts together of calculus. So this is where we actually physically state that the derivative is the opposite of the integral and vice versa. So that is part G of it, okay? You're gonna be like, wait, why do I have to do that? Well, it matters, because otherwise calculus is kind of a weird deal. I got integral, I got derivatives, y. That is the theorem that ties the two pieces together, okay? So part one, the definite integral in essence. Part two is the part where we actually get into talking about how they're married together, why they work the way they do. And we go from there. I guess I'll wait for those guys to get back to do that part. Okay? You gooch? It's almost fun. It's almost fun. Now today, I find it annoying the book talks about these integrals without giving you the context of, well, this is a function, right? So, but a substitution is not very hard. Later on, substitution will get a little nastier. We'll have to do double substitutions. Those are a good time. But again, the trick to this stuff is always find the antiderivatives, right? You with me? And so from now on, pretty much, not next week, but pretty much not next time, but pretty much every time from now on, you come to class, it's going to be, hey, here's a new trick to find another antiderivative. Ooh, I recognize the pattern group. Oh, yep, good. And just bang, 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 bust them on through. Questions, comments, concerns? What?
For assignment, it's 7 through 15 odd, and it says find the formulas for the function represented by the intervals. What does it mean by that?
What are you talking about there?
Like, what does it want us to find?
What are we doing? 7?
Yeah.
Evaluate the function using the fundamental theorem of caculus.
No. We don't have.
Which one are we doing?
So it's on 5.4.
I'm on 5. Did I skip 5.3?
Correct.
314 is not there?
No.
Well, then we're adding on an assignment.
Listen up, Tyler and
Tyler, we're adding. Apparently, Mr. Groom doesn't get his head up his backside, as per usual. Let's do 1 to 45. Every other odd. So was that about 10 problems? Give or take? And let the record state, Caleb, that if it's supposed to stop at 43, do 45 too. Because I can tell it already. 1, 5, 9, 13, 17, 21, 25, 29, 33, 37, 41, 40. Hot damn, 45. I did it right. Yeah, I grew. The crowd goes wild. All right, perfect. Dang, S&P is up again today. Up and down and up, back and forth.